is session 3 in probability. We'll be doing some problems on exercise 27a. Um, let's take a case. Problem number 2. Okay. A bag contains 3 white balls, 5 black balls, and 2 red balls. Do you understand this? I'm having a bag which contains 3 white balls, 5 black balls, and 2 red balls, all of the same shape and size. Why do I say all of the same shape and size? So when I put my hand inside, if there are different shape and size depending on the color, I can easily make out. If I want to pick up a red ball, I can choose, okay, this is a big ball, so it has to be red. So I don't give any chance like that. It says all same shape and size. A ball is drawn from the bag without looking into it. Now somebody puts in a hand and draws out one ball. Draws out one ball. Now what is the probability that this ball is black? What are the chances, what are the probable outcomes of getting a black ball? It's 5, there are 5 balls in that. How many total balls are there? There are 3 plus 5, 8, 8 plus 2, 10 balls. So the probability of picking a black ball is 5 upon 10 or 1 upon 2. Similarly, what is the probability of picking a white ball? Probability of picking a white ball is 3 upon 10, because there are 3 possible outcomes out of a total number of 10 outcomes. So it is 3 out of 10. Similarly, another tricky question is probability of not getting a black ball. We need to understand this in a better way. How many probable chances of getting a black ball is 5. So we have arrived at the probability of 1 by 2. Now P of not getting a black ball is 1 minus P of getting a black ball. Do you see this? So that is 1 minus half, it is half. Similarly, not getting a red ball. Not getting a red ball. That would be 5 plus 3. There are 8 chances where I won't get a red ball. So it is 8 upon 10. The other way of writing it is, what is the probability of getting a red ball? It is 2 upon 10. So probability of not getting a red ball is 1 minus probability of getting a red ball, that is 1 minus 2 by 10, again it is 8 by 10. Now there is a well shuffled pack of 52 playing cards. 52 playing cards. Now one card is drawn. I am drawing one card. Draw one card. The question is, what is the probability that the card is black? Let me represent B as black and R for red. What is the probability of getting a black card? We know that there are 26 black cards and 26 red cards. So we know that the probability is 26 upon 52, that is half. The second question is, what is the probability of getting a face card of red color? Face card of red color. Now how do we do this? How many red color cards are there? 26. How many faced red cards are there? In each there are two. One is the hearts, other is the diamond. So we have 3 of hearts and 3 from diamond. So totally how many cards? 6. So we can say that this probability of faced red card is 6 upon 52 or 3 upon 26. Okay. Now, if A and B are complementary events, if A and B are complementary events, we can say that probability of A plus probability of B is equal to 1. Why? Because probability of B is nothing but probability of non-occurrence of A. We know that probability of non-occurrence of A is 1 minus probability of A. So from this we can say that probability of A plus probability of B is equal to 1 because these two are complementary. At the same time, we need to discuss, let's say some probability is given 3 upon 5, 2.7, 43%, minus 0.6, minus 3.2 and 0.35. The question is, what are the valid values of probability out of these? We can say that is any probability of any event cannot be greater than 1, or probability of any event cannot be less than 0. Why? Because either an event can occur or it cannot occur, and so there is no meaning of having negative values here, so we can cross this right away, and no way it can be greater than 1. Why? We have seen that the probable outcomes and favorable outcomes. Suppose probability of E is means what? Favorable outcomes upon possible outcomes, right? So this means that this can never be more than this, so we can say that this can never be greater than 1, so we can rule out this. So 3 upon 5 is a valid. 43% is what? 43 upon 100, that is 0.43. Again this is valid. The third case is 0.35. This is also valid. The last example, a single letter is selected at random from the word probability. It's an interesting case. Probability. Find the probability that it is a vowel. It is a vowel. Now, how many vowels are there? We know that A, E, I, O, U. How many A's are there in this? 1. So, 1. Then, so let me write here. 1 plus E. No E's. 0. Plus I. 1, 2. 2. Plus O. 1. Plus U. 0. Upon how many total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the probability of getting a vowel is 4 upon 11. Are we clear about this? Okay.